up here picture, this is a picture of your whole assignment. Okay, I told you that I wanted you to do 1 through 6. This page actually was front and back, and it had a whole bunch of problems on it, and I did the first 6 and was like, and I'm done with this. That's enough. So your assignment is the first 6, and I'm going to work with you number 3 and then number 6. Okay, so if you're writing this down on blank paper, this is number 3. And when you go to write the other problems down, and you do 1 and 2 and 4 and 5 on your own, just make note that you already have this one worked out somewhere. Don't do it again. Okay. All right, so today we're solving systems, and these are systems of 3 equations. Note that up here you see not 1, but 2, but 3. 3 separate equations here, okay? And what else is funny about these that is different than what we did last week is a new letter. Anybody see the third letter? And Z. So we're not only working 2 equations in 2 variables, but we're solving 3 equations in 3 variables. And the first method that we're going to use, we're going to do this several days this week, but the first method we're going to use is called substitution. So when you go look, if you're having to reference this again later, if you go look at our playlist, this one will be called substitution. And it corresponds with that in Canvas. I titled that lesson. Okay? And so the substitution method I taught you before, I really like it when I can isolate a variable. I like substitution when it's very obvious that there is a naked letter. And so this is going to model a whole lot of what we did, I guess it was last week when we were working on the 2 equations and 2 variables. Okay, it's going to be very similar. It's just a lot longer process because there's a lot more going on here. All right. I like substitution. I actually hate it as far as this goes. This is so tedious and it's going to take a long time. Substitution is a useful skill though. And especially as we get into other problems in other classes in physics, I use substitution all the time. It's not ever that it's this involved. Okay. So, but I wanted to open your eyes to why would I want to use substitution? And it's a situation like this where they have y equals and they have y set aside by itself. Y is equal to all of this stuff. Can you see that? And they also have z equals. They've already isolated the letter z. As opposed to having these equations in standard form, x, y, z equals a number, right? You've seen that before. This is a setup where I would want to do elimination. But if I can tell that some variables have already been isolated, then I might go to substitution. I might lean more in that direction. Okay, so the first thing we want to do here is we want to get one of the variables in terms of the other, okay? And we're looking at this information up here, and they've given us y is equal to, if we had x and z, z is in terms of y, and then in this bottom equation, we have x and y, okay? It feels like we could go ahead and start plugging in some information. Let's go into this bottom equation here. This is equation number 3. Okay, I'm talking about this bottom one. And I'm going to let x be x because I don't have any other information for x. I don't have anything that says x equals. Okay, but I do have y in terms of z and in terms of x. And I have z in terms of y. So what if we plugged into, let's see. What if we isolated x in this equation? Okay, because I don't have an x equals anything. Do y'all see where I'm going with this? Okay, let's back up. Let's see if we can make this more clear. Do you see that I have y equals? Do you see that I also have z equals? Do you see that I don't have x equals? Okay, so we're going to go into this bottom equation. We're going to figure out what does x equal. So let's write it out. 2x minus y equals negative 4. Did y'all write all 3 equations down already? Okay. So I'm picking the bottom equation and I'm isolating x. I want to see what does x equal. So we're going to add y to the other side. So 2x is equal to y minus 4. Does this feel better? Like you know why we're doing this better now? Okay. Divide everything by 2. And so now I know x is equal to y over 2 minus, what's 4 divided by 2? 2. So y over 2 minus 2. There I have isolated x. Okay. So now I have x in terms of what? Y. And if I look at equation 2 up here, I have z in terms of what?
Y.
In terms of y. So it seems like I could pick the top equation and plug in my x stuff and my z stuff since they're both in terms of y. And then I'm down to only one variable. Can you see that? Okay, so we're going to write that top equation where it says y equals x plus z plus 5. But we're going to substitute out x and substitute in what? Y over 2 minus 2. We know that is what is equal to x. Plus z. But I'm not going to write z because I don't want two variables. I only want one variable. And I have z in terms of y right there already set up for me in that middle equation. So plus, open parentheses, negative 3y minus 3. Why am I opening parentheses here? Why does that matter? Yeah, so that I know exactly what I'm plugging in for. And so that if there's some number out in front, I know that I'm supposed to distribute. I'm changing my color here so you know that this was my x stuff that went into this red equation. Okay, and I'm not done yet. What else does y equal on the very end? Plus 5. Now we've got y in terms of y, and we can solve for y. Why, you ask? Because... Sorry, that was terrible. So we have y over 2 minus 2. And then we've got plus. And if there was any number in front right here, we would have to distribute it. But we don't. So we just have minus 3y minus 3 plus 5. And at this point, we can combine like terms. I have y equal to y over 2. Y over 2 minus 3. Y over 2 minus 3. So let's think about that. If I had a half a pi and I took away 3 pies, I could think of that 3 and 6 over 2. 1 over 2 minus 6 over 2. Negative 5 over 2. I agree. Negative 5 over 2y. And then negative 2 minus 3. Negative 5 plus 5. 0. So those cancel off. These actually take away each other. So I have y equals negative 5 over 2y. I need to get all of my y stuff on one side of the equation. So we're going to add 5 over 2y. We're just combining like terms. We're moving all the y stuff to one side. What do we leave on the other side? 0's over here. So does it even matter what's over here? I don't know. I'm going to add 5 over 2 to 1. What might I want to call that 1? 2 over 2? I could call that 2 over 2y plus 5 over 2y. Makes how much? 7 over 2y. And then what? Multiply by the reciprocal, 2/7. Good. Move it back over, he said. So these cancel. Y is equal to what? 0 times 2/7? 0. Ha. Once you get one variable, the rest of it's pretty fast. It's like you have to move one log to get the water to flow. Okay, we've got one thing figured out here. We know y is 0. So what can we do with that? Just plug into both equations for z and x. Let's go right here into our x equals equation. We've got this purple color, x equal to, and instead of y, I'm going to write 0 over 2 minus 2. What is 0 divided by 2? 0. What's 0 minus 2? X equals negative 2. Good. And then what's the last thing we're going to do? Find z. So we're going to get to plug into that second equation that says z is equal to negative 3 times 0 minus 3. So that part goes to 0. What is 0 minus 3? And so now we've come up with the solution here. It's not called an ordered pair. It's interesting. When we have a solution to 3 equations in 3 variables, we call it an ordered triple. Ordered triple. Okay. An ordered triple. So x is negative 2. We always put them in order, hence the ordered part. And then y, we got to be 0. And then z, we got to be negative 3. How would we go about checking this? Better plug them back in. Plug them back in. And if this is truly the solution, it's going to work in all 3 equations. So I want to look back up here at our equations and let's see if we come up with it. Okay. So if this equation is true, we get 0 on the left side, equal to negative 2 plus negative 3. What's negative 2 plus negative 3? Negative 5 plus 5. 0. So it works in the first one. Okay, let's move on to the second one. Z, so negative 3 is equal to negative 3 times 0, 0 minus 3. True? Okay, and the last thing, 2x minus y equals negative 4. 2x minus y equals negative 4. So 2 times negative 2. Negative 4 minus 0 is negative 4. Verified. Okay, it doesn't take very long to check them, and it's well worth your time to do that. Okay, if you made a mistake, you won't catch it if you don't check it. Cool? Everybody good? Okay. I also wanted to show y'all a graphical representation of what we're finding. So I'm going to pause this video right quick, and then I'm going to go find it. Okay. So this is a picture that your textbook shows of an ordered triple. What we're talking about is 3 planes. Okay, you know that you have your x plane, which is horizontal, and you have your y plane, which is vertical. What kind of plane do you think the z plane is? Could be slanted, could be forward and backward. Typically, that's what we see. We see the third dimension. So if I'm looking at x and y, it's flat. X is this way, y is this way. The z plane is the one that allows it to go through. That's what takes it from being a 2-dimensional picture to being a 3-dimensional picture where it comes off the page. Okay? But the deal is, we're finding solutions where the 3 planes intersect. So graphically, what that's going to look like is like this picture. You're finding the line or the point that they all have in common. If your planes never intersect, that's going to look more like option C down here. If only 2 of the planes intersect, that's going to look like option B. And if your 2 of them intersect together and the other 2 intersect together but they never all 3 coincide, that's going to look like A. So you could find a place where maybe x and y are equal. You could find a place where y and z are equal. You could find a place where z and x are equal, but never where x, y, and z are all intersecting. Okay? So anyways, I just wanted to bring your attention to like a visual, what are we finding when we're finding these intersections? It's hard to imagine when you're not used to seeing a third dimension. Okay, take it or leave it. I feel like leave it. It's fine. So this is number 6. This is another one of your homeworks. By the time that we finish this one, you'll only have 2 problems left that you're responsible for. 4 problems. You've got to still do 1 and 2, and then 4 and 5. Okay, so take a minute to get it written down, and then we'll talk strategy, and we'll see what moves we might want to make first. Do I get it? Okay. So in my opinion, and the jury's kind of out on this because this is just rough. There's not really any which way that seems better than the other. I'll tell you what I did, and then we can see if anybody else has a better option. I isolated Z. Because this equation says Z is equal to 4x plus 5y minus 14. Do y'all see that right here? I felt like it was easier if I would isolate Z in this equation in terms of y. Then I could find out what x is, and I could plug in that Z business right here, and I could get x also in terms of y. Then I could go into that Z sentence. There's about 1,000 different ways that you could go with this problem. Anyone see anything that they feel like is a better option or anything that you would do differently to start? You would isolate y?
Yeah, move it over like we did the last problem.
Okay. On this bottom one?
Yeah.
Okay. So I'm willing to try. I did this one. I just didn't feel like it was pretty, no matter which way we did it. What color do you want to use for the bottom equation to isolate y? I think it's helpful if I use different colors. You don't have to. Zaylee says pink. She always says pink. Okay, so in this bottom equation, we're going to isolate y. Another thing that I want to bring your attention to is when I write the letter Z, my Z's have a horizontal line through the middle of them. That is so that they don't look like my 2's. I think it's really helpful when we bring the letter Z into the mix that you can keep it separated from 2's. Okay, so my advice to you would be do something like that. Okay, so we're isolating y here, so that means we're doing what? Okay, so minus 2z and subtract 2z from the other side. So 3y is going to equal negative 2z plus 14. What else? Ooh, I see something. We could divide by the 3 here. But I think we plan on plugging it in to the top equation in this x equation, don't we? Was that kind of where we were going with this information? That's where I was thinking we were going with it. Is this a yes or a no? Look what this says up here in this x sentence. It says 3y. So does it feel like I could just pop this information right up there for 3y and I wouldn't have to get y by itself? Do you see what I'm saying? Or we could go ahead and carry on. I mean, it'll work out both ways. Go ahead and divide by 3. Divide everything by 3. But I just saw that and I thought, that looks pretty neat. But that may be more specific to this particular problem. Are our phones going crazy, y'all? Is there like an alert somewhere?
I don't know.
Okay, so in this top equation, it says x is equal to 3y, and instead of 3y, we're going to drop in 3 times whatever we just found for y. It's going to work out the same way both ways. I just thought that would be like a nice little shortcut, but it's fine. Minus 3z plus 8. Good, good. So x is equal to, when we push that 3 through, what's about to happen?
The denominators cancel.
Okay, so it's going to be negative 2z plus 14. Our denominators do cancel. 3 and 3 and 3. Those are all gone. Minus 3z plus 8. Bless you. Bless you, bless you. What we got here? X is equal to, when I combine like terms, I've got negative 2z minus 3z. What do we got? Negative 5z. 14 and 8. 22. Okay. This is nothing to write home about because I still don't have x solved for itself or y solved for itself, but I do have both of them in terms of z. Can you see that? So we substituted and we got both of those variables in terms of z, which means what can we do now? We can go into that z equation, which is that middle one right here, and instead of writing in our x stuff, we can put our x stuff in terms of z. And instead of writing in our y stuff, we can put our y stuff in terms of z. Are you excited about this? Okay, I don't blame you. It's kind of gross. So instead of x, we're going to put this blue business down here. I've got negative 5z plus 22 plus 5. And instead of y, I'm going to put this pink business I've got over here for y. Negative 2/3 z plus 14/3. And then I'm going to finish my z equation with minus 14. Oh, don't do this to me. Minus 14. Okay, so now we can start getting our stuff by itself, our z stuff. There we go. So z is equal to, we're going to distribute that 4. What do you got? Negative 20z. What's 22 times 4? Plus 88. Ooh, this is where it's yuck. 5 times negative 2/3. Let's call that minus 10/3 z. Am I going too fast? Well, you got 5 times 14. Anybody have a number on that? 5 times 14. 70. I think I got 70. So 70 over 3? It's okay. She's trying. 70/3 minus 14. Okay. All right. Now let's combine like terms. And eventually we want to get letters on the left side and numbers on the right side. For now, I'm content to just stay on the right side and consolidate. So negative 20z minus 10/3 z. What if we called 20 thirds? How many would it be? 60 thirds? 20 is also known as 60 thirds. Would you agree with that? So instead of 20, I'm saying call that negative 60 thirds. And we're trying to combine negative 60 thirds with negative 10 thirds. So what does that make? Negative 70 thirds z. Right. And then we've got 88 minus 14. What's a good number for that? 74. 74 plus 70 thirds. 74 plus 70 thirds. Let's see. 74 times 3 over 3. 74 times 3. 21, 22. 222 plus 70. 292 thirds. This is about to get better, y'all. So plus 292 thirds. That's what I got when I did 88 minus 14 plus 70 thirds. I got 292 thirds. Everybody okay? Y'all still breathing? But this is better than that. I told y'all, just so you know, this is better. Okay, so we got to move this z piece. So we're going to add 70 thirds to the other side. What's on this other side over here? 1z. So how else could I call 1 so that I could add 70 thirds? 3 thirds. 3 thirds plus 70 thirds makes me have 73 thirds z is equal to 292 thirds. 292 thirds. How do we get rid of the 73 thirds? Multiply by the reciprocal. I loved it. Multiply by the reciprocal on both sides. Okay, so our 3's cancel. We lost everything on the left side. Anybody have 292 divided by 73? Anybody got that number? Looking at you, Benedict. You got 292 divided by 73? What'd you get? 4. Thank you. You're my hero. He already did it. It's fine. I already did it too, to my credit. Yeah. All right, so it's 4. Z is 4. What does that do for us? Hey, we finally moved a log.
We ain't even done.
We're not. What can we do with that? Z equals 4.
Plug it in.
Where? Sure. You could plug it in for x into our x sentence. X is equal to negative 5 times 4 plus 22. What's that? Negative 20 plus 22. Negative 20 plus 22. X equals 2. Where else could we plug it in? Into that y equation, into that pretty pink one. Y is equal to negative 2 thirds times z, which is 4, plus 14 thirds. More thirds. What's negative 2 thirds times 4? Negative 8 thirds, good. And what if I have negative 8 thirds and I add 14 thirds? I get 6 thirds, which is, oh, that's a humdinger of an answer.
All right, we're done.
Y equals 2. Y equals 2.
Y and X are the same.
Y and X are the same. What's my ordered triple?
2, 4.
2, comma 2, comma 4. Dunskies. I did work the worst of the 6 problems with you. I picked the hardest of the 6. So I did 3 and I did 6 with you. You
put these on our test.
You need to do 1 and 2 and 4 and 5. Deal? 4 problems. Only 4 problems for homework tonight, guys. You're welcome. Okay.